Hi everyone. Before I begin, I'd like to show some credits to my summer class students for preparing this presentation. This has been wonderfully made, and so it would be a waste not to use this again. So, thank you to the students whose names you can see on the screen. Let's begin. So, in this presentation, I will be discussing these subtopics: the statistical quality control, plan, do, check, action, management information system, online analytical processing tools, tools to improve productivity and profitability. And these are your MRP1, MRP2, and ERP. And then lastly, I will be discussing total productive maintenance. Now, remember that these topics are always um, related to our major subject, which is your performance management system. So remember the why. Why do we study these topics? So always go back to the the major topic that we are to learn this semester. So let's start with the first subtopic. Okay, so we have statistical quality control. This is actually the application of statistical techniques to measure and evaluate the quality of what? Quality of a product, quality of a service, or quality of a process. So this is termed as statistical quality control. So in here, um, we will be encountering some terms that we have learned in our statistics subject. So I hope you can recall them. So there are actually two basic categories under statistical quality control. And these are the statistical process control and the acceptance sampling. So, statistical process control is the application of statistical techniques to determine whether a process is functioning as desired. So, if you want to evaluate the quality of a process, this is what you should use: statistical process control. Now, the second category is the acceptance sampling. This is the application of statistical techniques to determine whether a population of items should be accepted or rejected based on inspection of a sample of those items. Now, if you can imagine a manufacturing plant, the products are actually produced by batches or by lot. We call them batch or lot. So, to determine whether the quality of such batch or lot is acceptable or not, so we should use acceptance sampling. Of course, it would be a waste of time if we are to inspect all items in the batch. So, that is why we should only pick a sample, and then after evaluating the quality of the sample, we can now decide whether we should accept or reject the batch or lot. Okay. Now, for quality measurement, we can either look at attributes or variables. So, what are attributes? Attributes are characteristics that are measured as either acceptable or not acceptable. Thus, um, the attributes have only discrete, binary, or integer values. So again, either acceptable or not acceptable. Variables, on the other hand, are characteristics that are measured on a continuous scale. So it's not a black and white scenario, for unlike for attributes, wherein it's like black and white. If it's not black, then it's white. If it and vice versa. So it's either acceptable or not acceptable. So it's binary. On the other hand, variables are measured on a continuous scale. So We have here statistical process control methods. Statistical process control monitors specified quality characteristics of a product or service so as to detect whether the process has changed in a way that will affect product quality and to measure the quality of products or services. So, control is maintained through the use of control charts. So you can see here on your screen, this is a sample of a control chart. The charts have, you can see upper control limit and lower control limits. And when we evaluate a process, we can say that the process is in control if the sample measurements are between the limits. So you can see here the upper control limit and the lower control limit. If it is within the upper control limit and the lower control limit, we can say that the process is in control. However, if the um, after our computation, let's say the amount is over the upper control limit or beyond the lower control limit, then we can say that the process is out of control. It's not within our control. So that means it is actually a red flag. So this is the basic procedure in using control charts. So you have to set an upper control limit and a lower control limit. So as to how we can decide what is the upper control limit and what is the lower control limit, we will discuss this in the next slides. After setting an upper control limit and a lower control limit, we now select a random sample of either the process, product, or service, and the specified quality characteristic is measured. If the average of the sample of the quality characteristics is higher than the upper control limit or lower than the lower control limit, then the process is considered to be out of control. So again, we have attributes and variables, right? Again, for attributes, we can either say that it is acceptable or not acceptable, while for variable, this is measured on a continuous scale. Now, the control charts for attributes and for variables are different. So let's look at first the control charts for attributes. So for attributes, we have two charts. First is the P chart and second is the C chart. Now, what is the use of a P chart? P chart measures proportion that is defective. Okay, this is a statistical control chart that plots movement in the sample proportion defective, which is um, designated as P over time. So this is the formula to determine the upper control limit and the lower control limit. Remember that as step one, the in the procedure of using charts, step one is to set the upper control limit and the lower control limit. Now, if you are using the chart, then this is the formula. So upper control limit is equal to mu. This symbol is representative of the mean or average, or P. So we can actually replace this symbol with a P plus Z. Remember in your study of statistics, you have encountered the Z score, right? And then multiplied by the standard deviation or sigma. And then the lower control limit is the mean minus the Z score times the standard deviation. So here is an example. The process is to cut steel bars to a specified length. The samples taken found the mean to be 5.8 and the standard deviation is 0.01. So just simply substitute these values to our um, formula. So the mean, as stated in the problem, is 5.8. Then the z-score, you have actually a table for this, right? So the z-score for this is 3, and then the standard deviation is 0.01. So just do the calculation and you will get the upper control limit and the lower control limit. Now, in our case, I will not be expecting you to, or I will not be asking you to compute these upper control limits and the lower control limits because we are on the management side, right? Because our topic is performance management system. So we are on the management side. Our role is to interpret the data and not to compute the values. Okay. So for example, in my exam, I will just be asking you if the process is within control or out of control. So I will be simply giving you the amounts for the upper control limit, the lower control limit, and the average. From there, you can interpret whether such characteristic is acceptable or not acceptable. So here, since this is P chart and this is under the control chart for attributes, again, remember that for attributes, it's either acceptable or not acceptable. Therefore, if it is beyond the upper control limit or below the lower control limit, this is out of control. That means this is not acceptable. If it is within the control, if it is within our control, that means that this is acceptable, right? So another chart, oh, this is an example. For example, this is the averages of the samples. Okay, so all values are within our upper control limit and the lower control limit. So we can say that this is within our control and thus it is acceptable. So the next chart for attribute, still under attributes, is what we call our C charts. So C charts measures the numbers of defects per unit. So this is the formula to compute for the upper control limit and the lower control limit for C charts. So C bar is our mean. So the same with our P chart, right? So we start with a mean, but this time we will use the variable C to help us determine that this is a C chart. Okay, and then P for P chart. So C bar plus Z times the square root of C. So Z still represents our Z score. Okay, so again, this is just for academic purposes, but for our exam, I will not be asking you to compute the upper control limit and the lower control limit. I will simply give you the values and then you are to determine whether such process, quality of the product or service is within the control or out of control. Okay, so let's have an example here. ABC company is concerned with the number of defects in painted panels that it produces. The average number of defects in a sample is of 100 is 2. The company wants to monitor the process. 3 sigma control limits is used. So 3 here is our Z, and then 2 is our mean because it says that the average number of defects. So just substitute the values to our given formula and then you can get the upper control limits and the lower control limits. But take note that if you get a negative figure, always convert it to 0 because, for example, if we talk about products, there is no such thing as negative products. It's either there is a product or there's no product. So the lowest or minimum number should be 0. It should not be negative. Because again, there is no such thing as a negative product. So that's it for C charts. So again, remember for attributes, our charts are what we call P charts and C charts. Now, let's move on to variables. So for variables, we also have two control charts. First, we have the R chart, and then second is we have the X bar chart. So most of the time, the X bar and R charts are used together um, to look at the level of control that we have in the process by ensuring that the sample average and the range remain within the limits for both. Okay, so our chart is a type of control chart to monitor the process variability as the range when measuring small subgroups at regular intervals from a process. So R actually represents range. So that is why it's called R chart. So to compute the upper control limit of the R chart and then lower control limit of the R chart, we have the following formulas. So these ones we have constants based on the sample size. And then the R represents the mean or the average. Okay. So here we have an example. We have these samples, and then based on these samples, we were able to compute the mean and the range. So center line, this is actually our mean. So which is 1.46. And then the constants are given. So 2.57 and 0. So just compute the upper control limit using the formula and you can um, find out the values. And then second is the X bar chart. X bar, so meaning X with a bar on top. That's why it's called X bar. So X bar. X bar actually represents the average. So average chart. This is a type of control chart used to monitor the process average when measuring small subgroups at regular intervals from a process. So the upper control limit, this should be of the X, ha. Sayop siya butang diri. So upper control limit of the X bar chart, lower control limit of the X bar. So X bar plus A2 times R. R is our range a while ago. Okay, and then for the lower control limit, minus A2 times R. So these are your upper control limits and lower control limits. So again, to recap, we have two control charts for attributes, and these are your P charts and C chart. Then control charts for variables, we have X bar chart and R charts. Okay. So if you have any questions regarding the topics, feel free to message me through email in Canvas. So for P chart again, this is for proportion defective. So the procedure here is actually to just the same with the rest. Now just take a sample or random sample and then inspect each of them. To inspect the samples that you have chosen. Then determine the sample proportion defective by dividing the number of defective items by the sample size. And then plot the same proportion defective on the control chart and compare it with the upper control limit and the lower control limit to determine if the process is out of control. For the C chart, the same procedure. You have to select randomly one item and count the number of defects in that item. Then plot the number of defects on a control chart and then compare it with the upper control limit and the lower control limit to determine if the process is out of control. Okay. So we have other type of attribute sampling plans. We have the double sampling plan. This is a sampling plan in which a decision about the acceptance or rejection of a lot is batched, is based on two samples that have been inspected. A double sampling plan requires the specification of four quantities, which are known as its parameters. And what are these parameters or four quantities? We have N1, which is the size of the first sample. N2 is the size of the second sample. C1 is the acceptance number for the first sample. And then C2 is the acceptance number for both samples combined. So this chart here, or this flow chart, represents the process on how to conduct the double sampling plan. So again, you have to specify first two sample sizes, which are your N1 and N2, and two acceptance levels, which are your C1 and C2. So step one is if the first sample passes, meaning the actual defects passes C1, the lot is acceptable. If the first sample fails and actual defects are greater than C2, then the lot is rejected. If the first sample fails, but C1 is less than the actual defects, and the actual defects is also less than C2, the second sample is taken and judged on the combined number of defectives found. Okay. So here again, select the first sample of sample size, which is N1. Count the number of defects. And then if the defect is less than or equal to the acceptance number of the first sample, then you have to accept the lot. The lot or the batch is acceptable because if the defects are less than the acceptance number, then that means the defect is not that significant, not that material. So you have to accept the batch. However, if the defects are greater than C1, so you are doubtful, no, because the defects are greater than, more than the accepted number of defects. So do not immediately reject the batch or the lot. Compare it to your second acceptance number, which is C2. So if the defect, even if it is greater than the C1, if it is less than C2, proceed to the next step, which is to select a second sample size. So again, do not immediately reject. You have to select another set of samples. And then count the number of the defects in the second sample. If the combined defects of your sample 1 and the defects in your sample number 2, if the combined defects are all less than or equal to the second acceptance number, then you have to accept the lot. If the combined defects of both the sample number 1 and sample number 2 is greater than the second acceptance number, then you have to reject the lot. Here, if D1 is, or the defects in your sample number 1 is actually greater than the second acceptance number, then you have to immediately reject the lot. You don't have to go through the second step anymore because it, even if it is still the first sample, it is actually greater than C2. So there is no need for us to select a second sample. So you have to reject the lot. So that is what we call your double sampling plan. Then we also have acceptance sampling. The goal is to accept or reject a batch of items or a lot of items. Frequently used to test incoming materials from suppliers or other parts of the organization prior to entry into the production process. So, acceptance sampling is used usually in the assessing of the quality of the raw materials prior to its entry in our production process. So, for example, if we received raw materials from our suppliers before we have to use the raw materials in our production process, we have to assess first whether the quality of the raw materials are acceptable or not. So, acceptance sampling is used to determine whether to accept or reject a batch of products based on the number of defects in a sample. So an acceptable level is specified. So for example, our acceptable level of defects is, let's say, 100 units. So if the number of defects in a sample is less than or equal to the acceptable level, the batch is accepted, otherwise rejected and subjected to 100% inspection. So for example, when we receive raw materials and then we pick samples from the batch that we have received, and then let's say our acceptable level is 100 units. So after inspection, if we found out that the number of defective units exceed 100 units, then we have to reject the batch. But if, for example, based on our acceptance sampling, we found out that the number of defects is only 20 units. So it is way below our acceptable level, which is 100 units. So we have to accept the batch. Okay. Then we have the Shewhart cycle. This is known as the PDCA, Deming wheel, or PDSA. So PDCA represents plan, do, check, and act. So this is actually used for continuous improvement. So you can also relate this to your Kaizen. If you have a strategic cost management subject, you can use PDCA in your conduct of Kaizen costing. So PDCA, plan. P for plan. This provides a framework for our operations. It maps out the project's goals and clearly indicate the best way to attain them. So of course, before you assess something, before you act on something, you have to plan on it. So at least we have a vision in mind. And then after planning, we do. So testing of the plan, application of all steps described in the planning stage. So they should have D here, described in the planning stage. So what we have planned to do, we now do it. Okay, we now test our plan. If our plan is effective or not. And then after doing the steps that we have described, you have to check. So check is an analysis of the results of the operation. This is the most important stage because if we just do without follow through, without checking whether whatever steps that we have done are actually effective or not, without checking, then we cannot actually measure whether we have progressed or not. So check is the most important stage. Now, after um, analyzing the results of the operation, we have to act on the results. So, for example, if we find out that the steps that we have done here and under the do stage are not that effective, we can act on it by taking corrective steps. So, what should we change? Okay, but if we say that if we find out that the steps are actually effective, then we can now implement the solution to our problems. So, and then after which you go back to the plan stage and then do stage, check, and act. Remember that do and act are two different things. Okay, remember that. So you can ask yourself, can we apply this in our real life? For example, you plan on getting a good grades for your subjects this semester, so you plan on it. What are the steps that you're going to follow in order for you to achieve your goal, and then do it, and then check whether all the steps are effective or not, and then act on the results. You can also apply this PDCA concept in another aspect of your life, not just academic life. Okay. Then we need to proceed to MIS, or Management Information System. Management Information System is a systematic process of providing relevant information in the right time, in the right format, to all levels of users in the organization for effective decision making. MIS is also defined to be the system of collection, processing, retrieving, and transmission of data to meet the information requirements of different levels of managers in an organization. Now, remember, what is the main role of a manager? The main role of a manager is to make decisions. Now, how can you make decisions if what you can see are raw data? The data should speak among themselves. It should be presented in the right way. And it should be given to you, if you're the manager, it should be given to you the right time. Because there are some decisions that are very time sensitive. So if the report is given to you very late, or if on time, but it's in a messy format, then it will not be very useful to you as a manager. You might make a wrong decision based on it. So according to CIMA or CIMA, MIS is a set of procedures designed to provide managers at different levels in the organization with information for decision making and for control of those parts of the business for which they are responsible. So MIS comprises of three elements, and these three elements are the following. You have management, information, and system. Management, information, system. So let's break it down into its three elements. The concept of MIS is better understood if each element of the term MIS is defined separately. So first, we have management. A manager may be required to perform the following activities in an organization. First, determination of the objectives of the company or the organization and developing plans to achieve them, securing and organizing the workforce and physical resources so as to achieve the objectives that it has that the manager has laid down. Then exercising adequate controls over the functions performed at the lower level and to monitor the results to ensure that accomplishments are proceeding according to plans. So actually, management or a manager performs PDCA, right? So the manager plans, um, the manager um, allows the workforce at the lower level to perform or execute all the steps. And then the manager checks or monitors and acts on the results of the monitoring. So, thus, management comprises of the processes or activities that describe what managers do while working in their organization. They, in fact, plan, organize, initiate, and control operations. So, in other words, management refers to a set of functions and processes designed to initiate and coordinate group efforts in an organized setting directed towards promotion of certain interests, preserving certain values, and pursuing certain goals. It involves mobilization, combination, allocation, and utilization of physical, human, and other needed resources in a judicious manner by employing appropriate skills, approaches, and techniques. Next element is information. Information is data that have been organized into a meaningful and useful context. So it has been defined by Davis and Olson as this. Information is data that has been processed into a form that is meaningful. So the keyword here is meaningful. Meaningful to the recipient and is of real or perceived value in current or progressive decision. So, for example, data regarding sales by various salesmen or sales agents can be merged to provide information regarding the total sales made through agents. This information is of vital importance to a sales manager or marketing manager who is trying to plan for future sales. We have to convert data into information. Data is the input, information is the output. Data analysis or information processing converts data into information. Therefore, quality of data influences quality of information, right? Because garbage in, garbage out. So if your data is just garbage, then your output is also garbage. So you have to ensure the quality of your data because the quality of data influences the quality of your information, based on which management makes business decisions and translates these into actions through appropriate processes. So today, information and communication technology, or what we refer to as ICT, information and communication technology, also partakes in various processes which or with interfacial digital devices and local and global networks. Next, and the last element of our MIS is what we call system. System may be defined as a composite entity consisting of a number of elements which are interdependent and interacting, operating together for the accomplishment of an objective. So, for example, the human body. The human body is a system. And if you break it down into several systems, we have your digestive system. So, your digestive system is composed of several organs tending to the same purpose. Okay, so system is a composite entity consisting of a number of elements which are interdependent rather. So one can find many examples of a system. So for example, for a human body is a system consisting of various parts such as your head, heart, hands, legs, and so on. The various body parts are related by means of connecting networks of blood vessels and nerves. So, this system, our human body as a system, has a main goal which we may call living, to be alive. Thus, a system can be described by specifying its parts, the way in which they are related, and the goals which they are expected to achieve. A business is also a system because we have economic resources here, such as people, money, materials, machines, etc. And these are transformed by various organization processes, such as production, marketing, finance, etc., into finished goods and services. So, overall, if we look at MIS, Management Information System, Management Information System can be defined as a network of information that supports management decision making. The role of MIS is to recognize information as a resource and then use it for effective and timely achievement of organizational objectives. Here. So let's look at the potential impact of computers and MIS on different levels of management. So the potential impact of computers on top level management may be quite significant. Okay, here for top management, this is the topmost level of management. The potential impact of computers on top level management is very, very significant. An important factor which may account for this change is the fast development in the area of computer science. It is believed that in the future, computers would be able to provide simulation models to assist top management in planning their work activities. So, for example, with the help of a computer, it may be possible in the future to develop a financial model by using a simulation technique, which will facilitate executives to test the impact of their ideas and strategies formulated on future profitability and in determining the needs for funds and physical resources. By carrying by carrying out a sensitivity analysis with the support of computers, it may be possible to study and measure the effect of variation of individual factors to determine final results. Also, the availability of a new class of experts will facilitate effective communication with computers. Such experts may also play a useful role in the development and processing of models. So, in brief or in summary, potential impact of computers would be more in the area of planning and decision making. So, it is believed that top management will realize the significance of techniques like simulation, sensitivity analysis, and management science. The application of these techniques to business problems with the help of computers would generate accurate, reliable, timely, and comprehensive information to top management. So, if you are to compare the human process versus the computer process, of course, the computers will be able to process data faster than what um, a regular human employee can do, right? And then it could be free from errors because the computers are just following their programs. So if a human employee will be the one to compute something, then it is prone to human error. It may not be accurate. Such information will be quite useful for the purpose of managerial planning and decision making. Computerized MIS will also influence in the development, evaluation, and implementation of a solution to a problem under the decision making process. Okay, so we now discuss the potential impact of computers and MIS on middle management. The potential impact of computers and MIS on middle management level will also be significant. It will bring a change in the process of their decision making. So just like for top management. At this level, most of the decisions will be programmed and thus will be made by the computer, thereby drastically reducing the requirement of middle level managers. So some of the decisions will not be made by the manager anymore, but the decision will be made by the computer itself. So for example, in the case of inventory control system, the computer will carry records of all items with respect to the purchase of the inventories, the issuance, the use of inventories, and how much is the balance for the inventories. How many inventories are left? So these are all computed by the computer itself. So the reorder quantity for each item of material will also be stored in the computer after its predetermination. So, under such a system, as soon as the consumption level of a particular item of material will touch the reorder level, the computer will inform for its purchase immediately. Will already make the purchase. So, for example, our reorder level is 1,000 units. So, if the computer determines that the level of the inventory is already at the reorder level, so it will automatically create a purchase. So The computer itself will decide that it's time for us to purchase some more materials because the level of the inventory is already at its reorder level. The futurists also foresee the computer and the erosion of middle management as the vehicles for a major shift to re-centralization. The new information technology will enable management to view an operation as a single entity whose effectiveness can only be optimized by making decisions that take into account the entity and not the individual parts. So, next we look at the impact of computers and MIS at the supervisory management level. So, the impact in this level is maximum. At this level, managers are responsible for routine, day to day decisions and activities of the organization, which do not require much judgment and discretion. So, in a way, supervisory manager's job is directed more towards control functions, which are highly receptive to computerization. So, for control, such managers are provided with accurate, timely, comprehensive, and suitable reports. A higher percentage of information requirements of executives is met out at this level. So, the potential impact of computers and MIS on supervisory level will completely revolutionize the working at this level. Most of the controls in the future will be operated with the help of computers, whether we like it or not. Even the need of supervisory managers for controlling the operations will be substantially reduced. So if we have lots of supervisory managers, some of them may be laid off because some of their functions can already be done by the computer. Most of the operations or activities are now performed that are now performed manually will either be fully or partially automated. So, what are the objectives of MIS? Having in mind the concept of MIS and its impact to the different levels of management. So, what are really the objectives of MIS? So, the objectives of the MIS are the following: to provide the managers at all levels with timely and accurate information for control of business activities, to highlight the critical factors in the operation of the business for appropriate decision making, to develop a systematic and regular process of communication within the organization on performance in different functional areas, to use the tools and techniques available under the system for program decision making, to provide best services to customers, to gain competitive advantage, and to provide information support for business planning for future. So there are actually different levels of MIS as well. So we have the strategic level, tactical level, and operational level. So it will really depend on the purpose or the objective of having an MIS in place. So strategic level information systems help senior management to tackle and address strategic issues and long-term trends, both within the firm and the external environment. Their principal concern is matching changes in the external environment with the existing organizational capability. So it will answer the questions: what will be the cost trends? Where will our firm fit in? What products should be made, etc. So in other words, these systems are designed to provide top management with information that assists them in making long-range planning decisions for the organization. Then we have the tactical level information system. This serves middle level managers and help in taking decisions for a period of 2 to 3 years. The managers are typically concerned with planning, controlling, and use of summaries of transactions to aid them in their decision making. So, in other words, these systems provide middle level managers with the information they need to monitor and control operations and to allocate resources more effectively. In tactical systems, transactions data are summarized, aggregated, or analyzed. Their purpose is not to support the execution of operational tasks, but rather to help the manager control these operations. So, again, for a strategic level of information system, this actually refers to the top management. This helps the top management. Tactical level helps the middle management. Then the last level of information system is what we call operational level information system. These are typically transaction processing systems and help in the operational level um, managers to keep track of elementary activities or basic activities and transactions of the organizations, such as sales, receipts, cash deposits, flow of materials, etc. Their purpose is to answer routine questions and to track flow of transactions. Thus, the primary concern of these systems is to collect data, validate, and record transactional data describing the acquisition or disbursement of corporate resources. So, thus, each type of information system serves the requirements of a particular level in the organization, providing the needed basis for decision making. So, again, strategic is the strategic level is to help the top management. Tactical level is for the middle management, and then operational level is of help to the supervisory level of the management. Now let's discuss OLAP. This is one of the subtopics for this presentation. So OLAP, or online analytical processing. OLAP is a category of software technology that enables analysts, managers, and executives to gain insight into data through fast, consistent, interactive access to a wide variety of possible views of information that has been transformed from raw data to reflect the real dimensionality of the enterprise as understood by the user. So the OLAP functionality is characterized by dynamic multi-dimensional analysis of consolidated enterprise data, supporting the end user analytical and navigational activities, including calculations and modeling applied across dimensions through hierarchies and or across members. Trend analysis over a sequential time periods, slicing subsets for on-screen viewing, drill down to deeper levels of consolidation, reach through to underlying detailed data, rotation to new dimensional comparisons in the viewing area. So OLAP is implemented in a multi-user client or server mode and offers consistently rapid response to queries regardless of database size and complexity. OLAP helps the user synthesize enterprise information through comparative, personalized viewing as well as through analysis of historical and projected data in various what if data model scenarios. So this is achieved through the use of OLAP server. So again, for OLAP, this is when we have a multi-user. There are different users, many users of a server. So each user is actually interested in a different um into a different view or analysis of a specific data. So by the use of OLAP, the reports could be catered in such a way that um it will really address the need of that specific user. So it's not a fixed presentation of data, but rather it could be personalized depending on the need of such user. So OLAP server is a high capacity multi-user data manipulation engine specifically designed to support and operate on multidimensional data structures. Of course, we know that for every computer system, we have a server. So for if we are using OLAP, then we have an OLAP server. Then we have the OLAP cube. OLAP cube, or this is a multi-dimensional cube or a hypercube. This is a screenshot of data at a specific point in time. It can store and analyze multi-dimensional data in a quick but logical manner. It consists of numeric facts called measures, categorized by dimensions. So measure is a set of labels or metadata associated with it. The dimension describes the labels. So for example, a cube that contains store sales as a measure and date or time as a dimension. So if we have there um, a list of or call this a record of all the store sales, then we can actually drill it down into a specific date or time. So each sale has a date or time level that describes more about the sale. So this is the OLA process. This is how data is prepared for OLAP. Okay, so we have here the different data sources. Okay, and remember for OLAP, this is more of a multi-user server. So let's say we have here the first data source, second data source, and then the other data source. All data will be stored in the data warehouse. And then the OLAP cube has, remember, the OLAP cube has a measure and dimension. Okay, so if you are one of the users, you will input app queries. So what do you need to, uh, what report or what information do you need to see in your screen here? Okay, so the app queries the answer to the app queries will be taken from the OLAP cube and then will be displayed in the screens of the user that is making the query. Okay, so this is one of the processes that the OLAP cube can perform. So you have here the OLAP cube, and then you can actually drill it up and dice it. So one aspect and then drill it down into several aspects. You can roll up. You can slice it. You can pivot it. Okay, but actually, this is we we cannot see this in our through our naked eye. Okay, this process is merely done in the background, meaning it's the computer's problem. It's not our problem. Okay, but this just shows how the processing is done behind the scene. Okay, now we have types of OLAP. We have MOLAP or multidimensional online processing. This is the classic form of OLAP and is sometimes referred to as just OLAP. Okay, since it is the classic form or most basic form of OLAP, the MOLAP, sometimes it's just called OLAP. Okay, MOLAP stores this data in an optimized multidimensional array storage rather than in a relational database. Therefore, it requires the pre-computation and storage of information in the cube or the OLAP cube, the operation that is known as the processing. MOLAP tools generally utilize a pre-calculated dataset referred to as the data cube. The data cube contains all the possible answers to a given range of questions. So just like what we have seen in the previous slide, um, the answers to all queries will be taken from the cube itself. MOLAP tools have a very fast response time and the ability to quickly write back data into the dataset. Another type of OLAP is ROLAP, or Relational Online Analytical Processing. ROLAP works directly with relational databases. The base data and the dimension tables are stored as relational tables, and new tables are created to hold the aggregated information. Depending on a specialized schema design, um, the roll up, the main dif- difference or distinction between roll up and MOLAP is that MOLAP uses data cube, while roll up uses tables. Okay. This methodology relies on manipulating the data stored in the relational database to give the appearance of traditional OLAP's slicing and dicing functionality. So, in essence, each action of slicing and dicing is equivalent to adding a where clause in the SQL statement. I'm not sure if you have this subject in your prospectus, but at my time we call it AC 505 database management. So I'm sure uh you've experienced adding queries through SQL. I hope so. So rollup tools do not use pre-calculated data cubes, but instead post the query to the standard relational database and its tables in order to bring back the data required to answer the question. Rollup tools feature the ability to ask any question because the methodology does not limit to the contents of a cube. Rollup also has the ability to drill down to the lowest level of detail in the database. Another type of OLAP is your HOLAP, Hybrid Online Analytical Processing. There is actually no clear agreement across the industry as to what constitutes HOLAP or hybrid OLAP, except that a database will divide data between relational and specialized storage. So, for example, for some vendors, a whole app database will use relational tables to hold the larger quantities of detailed data and use specialized storage for at least some aspects of the smaller quantities of more aggregate or less detailed data. HOLAP addresses the shortcomings of MOLAP and ROLAP by combining the capabilities of both approaches. So, best of both worlds. That's HOLAP. HOLAP tools can utilize both pre-calculated cubes and relational data sources. So, under HOLAP, it's actually a combination of MOLAP and ROLAP. So, for HOLAP, it uses both tables and data cubes. So let's compare one from the other. So each type of OLAP has certain benefits, although there is disagreement about the specifics of the benefits between the providers. So some OLAP implementations are prone to database explosion or MOLAP, a phenomenon causing vast amounts of storage space to be used by MOLAP databases when certain common conditions are met. High number of dimensions, pre-calculated results, and sparse multidimensional data. MOLAP also generally delivers better performance due to specialized indexing and storage optimizations. MOLAP also needs less storage space compared to ROLAP because the specialized storage typically includes compression techniques. ROLAP is generally more scalable. However, large volume pre-processing is difficult to implement efficiently, so it is frequently skipped. Roll-up query performance can therefore suffer tremendously. So, more fast um, return or answer to the queries is with MOLAP rather than ROLAP. Since ROLAP relies more on the database to perform calculations, it has more limitations in the specialized functions it can use. So HOLAP encompasses a range of solutions that attempt to mix the best of ROLAP and MOLAP. It can generally pre-process swiftly, scale well, and offer good function support. Actually, here, I think there is an error with the presentation, but this one, this list is for MOLAP. So, as to what I have mentioned, that is what is for HOLAP. It is a mix of the best of ROLAP and MOLAP. There are also other types of OLAP, but not so common. These are sometimes used, although they are not as widespread as MOLAP, ROLAP, and HOLAP. So we have WOLAP, web-based online analytical process; DOLAP, desktop online analytical process; or TOLAP, or real-time online analytical process. Okay, I hope you understand the basic concept of OLAP. Now, at this point, let's distinguish endogenous variable and exogenous variable. So, they are the observable variables, and usually they are more variables than the number of equations in the model. Some of the variables are supposed to be determined by forces completely outside the model, and their values are assumed to be given. So, such variables are called exogenous variables. Variables like um, government policy, population, etc., are samples of exogenous variables. X meaning outside variables. It is treated like a parameter in solving the equations of a model. The variable whose values are determined by the system when parameters, disturbances, and exogenous variables are given are called endogenous variables. Endogenous variables cannot affect the value of exogenous variables because, again, exogenous variables are only those that are taken from outside our organization. So, endogenous do not affect exogenous, but the values of exogenous variables influence the value of endogenous variables. Okay. So endogenous variables are observable variables. As what I have mentioned a while ago, there are more variables than the number of equations in the model, treated like a parameter in solving the equations of a model, so and so on. Okay. I guess there are several discrepancies or errors in the presentation, but what will prevail is what I have mentioned, okay? So you need to pay attention. And then we have the type 1 error. The decision to accept or reject the null hypothesis, or H0, is made on the basis of information supplied by the sample observations. It is possible that the conclusion drawn on the basis of a particular sample may not be true in the aspect of population. So, when the test procedure rejects a hypothesis when it ought to have been accepted, it is called a type 1 error. So, again, if the procedure rejects the hypothesis when in fact it should have been accepted, that error is what we call a type 1 error. Next, we have null hypothesis. It implies a neutral and or non-committal attitude of the statistician in testing the hypothesis. It is a hypothesis of absence of relationship or absence of difference between sample static and population parameters. Next, we have level of significance. The validity of a hypothesis is against the alternative hypothesis tested at a certain level. The level of significance determines the confidence within which a statistician accepts a null hypothesis. 5% is the level of significance, and 95% is the level of confidence. R square is the measure of goodness of fit. It measures how well the regression line fits the observed data. Actually, these terms are more useful to a statistician. So our goal is simply to familiarize ourselves with these terms, not necessarily uh, we become experts on these. So at least we know what these are. Okay. Then we have a type 2 error. And the test leads to acceptance of a false hypothesis. It is called a type 2 error. Critical region. While accepting or rejecting a null hypothesis at a given level of significance, the region of rejection is called as critical region, whereas the other region is called as region of acceptance. Problem of identification. Problem of identification implies out whether numerical estimates of the parameters of the structural equation can be obtained from the estimated reduced form of coefficient. If this is possible, then we say that the equation is identified. Okay, identification problem arises only for those equations which have coefficients which have to be estimated statistically. Okay, and then we have the structural form and reduced form of simultaneous equation model. The structural form describes the structure or behavior of the economy or of a producing firm in an econometric model. The reduced form expresses the endogenous variables only in terms of the predetermined variables and the stochastic disturbances. So I understand that these terms are very, very technical. So again, our goal is to simply familiarize ourselves with these terms. These terms are actually related to our understanding and analysis of the endogenous and exogenous variables. Okay, next we have the MRP. Okay. So for MRP1, MRP2, and ERP, I think I'll just discuss this in another video because I need to cut this one first because I have an important matter to attend to. So for MRP1, MRP2, and ERP, I will be uploading a separate video on these remaining topics. Okay. Thank you. And if you have questions regarding the topics that I have presented so far, don't hesitate to message me and Canvas through email. Thank you.